Welcome everyone to the Winter 2023 class of Biotechnology and Society, BIO211. Although I have posted my introduction in the Blackboard area, on the Blackboard content area on your left-hand side, but still, it's good to be, in a setting like this. So my name is Shiraz Mujtaba. My educational background is that I am a PhD. I did my PhD in molecular biology of HIV virus, and also studied the pathogenesis of AIDS, which is caused by HIV infection. So I am at this point a professor in the Department of Biology, and if we were on campus, then my office is located on 4th floor of AB1 building, that is 1638 Bedford Avenue. But we are in a synchronous setting. So what matters is Zoom link, right? So we are here because of Zoom link or Zoom settings. So I believe most of you. So in this class there are 35 students. And I see that 26 students are attending the class, 25 students are attending the class. So, I believe there are no issues with my Zoom link. And I mentioned to you, the first thing is that if you don't have access to Blackboard, then you must contact the Blackboard office or contact your advisor for guidance. There's no way I can help if Blackboard is not working at your end. Why I say that? Because we are going to make progress very fast, and for each chapter you will be having an assignment, and that will have a deadline. So it's very difficult for me to get assignments delayed, or get a delayed assignment and then catch up, because I have to, at my end, I have to move with the progress of the syllabus, and troubleshooting these kind of issues is not in my hands. I have no control over Blackboard. So please make sure your Blackboard is working good for you. So coming back to the title of this class, which is Biotechnology and Society. So biotechnology is formed by fusing two words. One is, of course, biology, and other is technology. Right? So why biology and technology, they have come together? So these two have come together mainly to improve the conditions of living organisms. Now, you can ask me that why I say living organisms. It's because we don't only care about ourselves like human. I can always say improve the living condition of human beings or us, but that's a given. Why I say organism? Because we need to take care of the plants. We need to take care of our ocean, which is inhabited by aquatic organisms. We need to take care of our soil. Why soil? Because soil is the major platform for doing one of the oldest profession, that is agriculture. And we depend upon plants as one of the most primary meal. So if the soil is not good, how will the agriculture as a profession progress, right? So ocean, both water quality, the waste, taking care of the waste, improving the lives of organisms, For example, if I don't know whether you would be able to remember, but there was a big spillage on the Gulf area in the area of New Orleans, Louisiana, and that area, where a gas company, petroleum company, had a major accident, and the whole ocean was covered with crude oil, and that impacted, because the crude oil, if it sits on the top of the ocean, it cuts. One of the things that it will definitely degrade the quality of water, and that water consumed by organisms can be poisonous. Second, it can control the oxygen carbon dioxide exchange because it is covering the top layer of the water. So all these can affect ocean. So how do you clean up such kind of disaster? So you need some genetically engineering algae that can eat up or consume or metabolize these kind of waste product, plastics, crude oil, so on and so forth. So technology and biology have come together to improve the living conditions on this planet. And if I come back on humans, so all we have witnessed in past 3 years is emergence of a I won't say new virus, because coronavirus was already known, but perhaps emergence of a very aggressive form of coronavirus, which is called, we all know that it's called COVID-19. And one single virus, it multiplied so fast within few months. Possibly the first virus was detected in November mid 2019, and by 2020 March, June, the whole world was shut down, right? So one virus, one viral strain. So how did this impact us? This impacted us in many ways. Of course, health faced a major consequence, but business, right? Jobs, education, many things was stalled, almost stopped. And we had no hopes, right? The way things were happening, the ambulance siren on the streets, the stressful frontline workers, right? Health workers, they were so much stressed across the world that we needed something to give us hope, right? And so the hope was vaccine. Whenever there is an infectious disease, the hope is vaccine or a medicine. Medicine is still not possible for COVID-19, maybe in future, effective vaccines, but effective medicine, but vaccine it came out, I believe, by the end of or early 2021. People, especially the healthcare workers, the frontline healthcare workers, they started getting vaccinated. So how this vaccine came, right? So this vaccine was very innovative. This was one of the first vaccine that was made by using mRNA. And this mRNA was injected in the muscles, upper arm muscles. And this mRNA gave us immunity. And slowly, as population got immunized in different countries, different, people could handle the pandemic, right? And now we got 2 shots, and we are getting boosters. The traveling is easy, but we still don't know what's going to happen, right? There could be some new strain, there could be some old strain. Now we are hearing that in water, drinking water, scientists have detected polio virus. Now, poliovirus was a disease which was to happen long back, possibly half a decade back. And scientists or health care workers or physicians or doctors, they got control over polio was again because of the vaccines. Now, the difference between in that time polio vaccine and today's COVID-19 vaccine is polio vaccine was protein based. Polio vaccine was protein based, whereas COVID-19 vaccine is mRNA based. Two different strategies, right? So what is the basis, right, that scientists could have two different strategy for two different viruses? It's because of technology. But what is essential for technology? One of the most crucial thing for technology is to become successful is to have a fundamental knowledge, right? Fundamental knowledge. And this fundamental knowledge comes from research, right? Research. Now, this I'm talking about vaccines, right? In 1800s, James Watt, from UK, British, he saw the power of steam when he was very young child, and he could see that steam. What is steam? Is when you heat water, you get steam, right? So that steam, that vapor, that water vapor from water, boiling water, has immense power. And from that steam, he developed, for that steam to utilize its full potential, he developed his own workshop. And in that he developed a panel of products like railways, right? Initially, the railways, the old railway model, they used to use steam, they used to use coal. Steam was also used for many mining purposes, right? Mining was one of the most earlier profession to take out natural ores from Mother Earth. And these mineral ores were purified and developed into products that could be utilized. Nowadays, we get mostly synthetic product, but initially human civilization in 1800s, 1700s, mining was a big profession. Whether it was iron, whether it was coal or limestone, you name it, we were dependent upon. Still we are dependent upon gas for our car. So technology may not only relate directly to biology, but human lives can be impacted by doing research and trying to develop tools that could help the human civilization. So one product can affect the whole civilization, right? At this given point of time. So let's say 50 years back, the discovery of successful polio vaccine. So what polio virus used to do? Polio virus, the favorite site is to infect the endings of the nerves. And when it infects the ending of the nerves, it blocks the communication between the neurons, the nerves, and the muscles. So the muscles would not develop. The nervous system and muscles would not communicate. So people had physical disability because of polio. Whichever part of the body it would infect. It was a very serious disease, and it would infect mostly kids. So especially those kids who were not very immunologically strong. Now polio vaccines are given in the first week of the birth, or maybe earlier. Now coming back to COVID-19. So as I mentioned to you, that polio virus vaccine was protein-based, and COVID-19 vaccine is mRNA-based. So where does the term protein and mRNA comes from? So this term comes from biology, right? And in biology, how it comes in biology? Because we know that DNA is the primary genetic material. in maximum, in majority of the organisms, right? And this DNA can serve as a template to synthesize RNA. And mRNA is one of the RNAs. mRNA is one of the RNAs that is synthesized by DNA. And then this mRNA can serve as a template to synthesize proteins. So this pathway, this very pathway is the central rule of biology, right? So where did proteins come from? Proteins come from the simple biological concepts, right? Simple biological concepts. So if we don't understand the fundamental of proteins, how can we make, vaccines for poliovirus? If we don't understand the fundamental concept of RNA and mRNA, how can we make mRNA-based vaccines? And, just keep track. If you have interest in science, biology, then keep track of mRNA products. It is going to revolutionize the cancer vaccines big time. A lot of research, is going to take a speed because of this success of this COVID-19 vaccine. So coming back, I hope, I was able to convince you that fundamental biological concepts, when they get married with technology, it can improve. It has a huge impact on society, positive. It could have negative impact also, right? So when industrialization happened, right, a lot of small-based industries, they lost. I'm talking in terms of history. Whenever there's a change in social structure, there's an impact, right? So technology, we are becoming so much used to technology, which is fast-paced, that sometimes we don't account that technology can take over jobs, right? For example, if you go to if you travel out of US, there are many places where you don't have security, people. You just scan your passport and then you enter into that country. There is no customs, there is no hassle. But perhaps the technology is so it's a shift. When new things come up, it also creates space for new directions. So technology. So coming back to biotechnology and society, we can see that biotechnology is very effective field of biology. And also, what I want to tell you that next 50 years or next 100 years, health-based careers, health-based jobs, there will be a lot of promising avenues for health-based careers, health-based jobs. So biology and disciplines of biology are going to play a huge role. Now, at this point of time, I also want to mention that biology has become integrated with computational science also. Why do I say that? Because remember, artificial intelligence or contact tracing that happened during COVID-19 is because artificial intelligence and biology, to get analysis of data, what's going on, which area the virus is more hotspots of virus prevalence, they all could be possible because of contact tracing, right? And depending upon the contact tracing, you can, the government decides to whether to, to implement lockdown or to relax the lockdown, and so and so forth. So biology is not only related to vaccine or DNA or mRNA, but it has a wide consequence. Okay, so at this point of time, I would like to know whether you have any questions for me. And if there are questions, then please put it in the chat area so that I can address those questions. And I see no questions. Then I would like to move to the next stage of the syllabus. That's why I have this map on the front page of the syllabus, that medicines, health, they bring the world together, because no matter we are geographically located in different part of the world, but we have similar challenges with respect to especially diseases. So right. So let's look at the course overview. So syllabus is like template that I try to adhere to during my teaching, and that keeps me to know my progress. This helps you to know where the class is going, especially if you have a short winter session. So let's look at the overview of this course. I'm here at this point of time. So biotechnology is a course designed to introduce students to the field of biotechnology. And I mentioned to you, explained to you, and its application and the impact of modern biotechnology on the society. So here there is a word that says modern biotechnology, right? So what is modern, right? So here I would like to define what is my modern biotechnology. So historically, if you look, and if I ask you a question, that when did biotechnology develop? So different people could have different answer. So my take is that biotechnology developed when human civilization began to settle down, because in the initial year, humans, we used to move from one place to the other in search of good climate or food or security. But at certain point of, as civilization grew, families went, community grew, humans, they decided to settle down and at a particular location. And they were wise enough to settle down on the bank of rivers. And the major reason was accessibility to water. Now, when humans, they got restricted at a particular location, they had to do something about the food, right? So to make the food available for themselves, they cannot move, they are stationed. So at that point of time, they thought of developing agriculture, right? So agriculture was perhaps one of the first, because for agriculture, you need tools. You need to put seeds in the soil, make soil friendly to grow the crops. And the second was the dependent of human beings on pets and animals like horses, cows, and sheep, and they started taking care. So on one hand, agriculture was one of the first profession or first technology that humans adopted, right? On the other hand, there were disadvantages of settling down also. So one of the major disadvantages was they came in when they took up agriculture as their primary profession, they came in close contact with soil. And when they came in close contact with soil, bacteria, right, like anthrax. When they came in contact with animals, they got a lot of viruses from animals, right? So on one hand, they were people settled down, but on the other hand, because of the close proximity with soil and animals, humans became susceptible to many kinds of diseases, right? So this part of biotechnology I'll be covering in every lecture. Here I just try to explain to you the significance of this course, and that's the way to start when you're discussing the syllabus. But all these advancements are based upon basic concepts of DNA, right? and human diseases, right? There are genetic diseases which could be very, very problematic, you know, and especially in kids who are born with certain kind of gene changes, gene mutation, and that can affect the life of a kid. And when a life of a growing small kid is affected, the whole family gets affected, right? So we are going to study basic concepts of DNA, how DNA is inherited, right? And what is, if you look at our body, we look into mirror every day, and but if you look at in a different way as a biologist, you'll feel that you will realize that our body is nothing but a trillions of cells, right? Skin. What is skin? Skin is a type of tissue, the largest tissue on our largest organ of the body, but the fundamental unit is cell, our cells. So there are trillions of cells in our body. Our body is composed of cells, tissue, organs, and organ system. That's how our body runs, right? And the moment something happens, then we become sick or diseased. So these cells are fundamental unit. They're actually a factory in themselves, they're industry in themselves, right? And cells, they don't only work at individual level, but they work together also with neighboring cells. So our body, which is made up of trillions of cells, cells form tissue, they all communicate to each other, right? Communication. Right now we are communicating through electronic Zoom, right? Which is a combination of computer science or computational technology plus internet, right? So where does this comes from? The basis is communication. So our cells also communicate with each other. The brain communicates with right? If you want to lift your hand, your brain says to lift your hand. It's communication, right? So our body is made up of cells which communicates very efficiently, and any breakdown of this communication can lead to the disease. So let's say it's raining right now, there's a high wind, and I lose the power at my home or in my office. Then I can't connect with you through Zoom, right? So there's a total failure. So this communication in our body is a message that's the way to the society will shape up, right? And so biotechnology is just not related to vaccines, but it has far-reaching consequences, right from medicine to agriculture, the quality of soil, the quality of ocean. Even we have to take care of the algae. Right? There are predictions that because of genetically modified plants, we could lose beautiful butterflies, right? Beautiful butterflies that prey on the leaves. They have their life cycles, may not be able to eat up those leaves. They could be pest resistant, so we could lose. So that's another side of technology, right? So those are predictions that, but as human beings, it was our nature or it was the compulsion. We always go for things which would help. And one of the reasons is that increase in population, right? How to generate products that would cater to the whole world, right? And as I mentioned to you, this whole world, right? Why I'm mentioning to you? Because diseases like diabetes, right? Diabetes is a disease where it happens because of malregulation or dysregulation of sugar in our body. And this diabetes could have serious consequences on somebody's life. Now, because of our change of our eating habit and many other factors, diabetes that used to happen in senior people, now it happens in small kids. So we need how to treat diabetes. There's only one medicine. One of the medicines is insulin. How do you produce insulin that would cater to the whole globe? So you need technology. So this is a very interesting course. It's a very powerful course, which engages you, and also on one hand, so I could say that this course, if you look at the syllabus, you can divide this syllabus into two parts. One where we learn about fundamental concepts of biology. And the second part is to look at the applications of these concepts, right? So this was the course overview. Now, what are the objectives of this course? This is the most important aspect of a syllabus. That what are you going to learn? What I'm going to teach to you? What I should make sure to my best that you learn. So these are the 9 points that I am hoping that you will be able to learn and I will be able to effectively teach. So I have been teaching this course since maybe spring of 2014, so a number of years. And I teach every semester this course, winter, spring, summer 1, summer 2, fall, so across the year I've taught. So you can multiply how many times I have from 2014 to until now, how many courses and how many students I have taught this course. And I also really enjoy teaching this course, right? So there's a huge, canvas that this course covers. So discuss the definition of biotechnology, which I did, history of biotechnology, which we just, and I'll keep coming back to you and emphasizing the role of biotechnology, positive, negative. It's like any technology is just like cell phone, if you can use it for good purpose, if you overuse it, may not be good for your eyes and sleep, so on and so forth. So technology has that double-edged sword kind of, so fundamentals of modern biotechnology, demonstrate the knowledge. I'm covering point number 2, demonstrate knowledge of basic biology of prokaryotic and eukaryotic cells. So from tomorrow, we'll go into chapter 1. Chapter 1 will talk about various macromolecules in our body or biomolecules in our body that supports the cell, which is the fundamental unit of life. Once we learn this about molecules, we will learn about cells, because these molecules support the cell. So we study various cellular functions, how a cell is supported by various organelles. Then what is the fundamental unit of a living organism? What is the fundamental, let me frame this sentence again. What is the fundamental significance, or what is the fundamental quality of a life, right? A life could be a simple bacterial cell, a life could be human being. So the basic concept is that we all want to grow, right? Bacteria wants to grow from 1 to 1 million. Algae, fungi, plants, they all want to grow. So growth is the essence of living organisms. In talking in terms of humans, growth would mean cell division. From 1 cell to 2, 2 to 4, and on a logarithmic scales, there could be trillions of cells, right? So cell division is the essence of living organism that we will study in chapter 2. In chapter 3, we will look into what are the functions of DNA, RNA, and proteins. In chapter 4, we will study about genetics, how genes or how the characters are inherited. And it's possible that if you have taken BIO211, you might have gone through these. So there could be a overlap also. But this is more an applied course. But when you are studying application, it is important to revise some of the basic concepts also. After chapter 4, we go into the applied aspect of this course, which is recombinant DNA technology. How to scale up the production of, let's say, for example, COVID vaccine, right? How to scale up the production of insulin so that diabetes is under control. And then we look at the effect of technology on soil, on water, and so on and so forth. So these 9 points are the umbrella, important points that becomes the backbone of this syllabus. it is very important that as we make progress, we come back to this SLOs, that are we learning or not? So progress is just not movement from chapter 1 to chapter 2 to 3 to 4, 4 to 5, but we also understand the objectives that, whether the syllabus is or this course is good for your knowledge. And so I'll come back to this. I'm scrolling down. So this is the grading thing. So any activities that you do has points. Homework assignment in this synchronous settings, homework assignment becomes a very important part. Right? So homework and assignment is 20%. Discussion board, an activity that you did earlier today, in the beginning of the class, it's 10%. So all these small things count, right? And why I'm saying small, because small things, they come together to occupy, to make it a larger contribution. You might say, okay, there's only one discussion board, let's skip it. But once you get into a habit of skipping, then you try to skip 1, 2, and then you ultimately end up losing 10% point. The 10% point can change your grade from let's say B to A minus, or A to A plus, something like that. So each and every activity, assignments, and then we'll have here, I have mentioned weekly and bi-weekly quiz, but this is winter session, we are making progress every day. So quizzes will be either alternate day, depending upon the length of the chapter. So quizzes could be, most likely, it will be alternate days, or at least twice in a week, twice or thrice in the week. Midterm is 20%. Now, another important thing is term paper. So I'll describe about term paper in tomorrow's class. But term paper, students think that, oh, this is an extra work or too much of writing. But I have seen that term paper, 15% point plays a significant role. Some students may not like biology, may not like science, may just like English or literature. So for them who are not doing good at quiz on their own expected lines, term paper is one of the biggest help. So you want to be English person. So I'll talk about the details of term paper tomorrow, and then the final exam. So the final exam will be on the last day of the class, right? So quizzes, midterm, and final exams, all these will be of multiple choice questions. So I will, do you have any questions about at this point of time?
Yes. Also, do we get homework, or we just got to study and then we take our exams, the midterm and finals?
No, homework is you do the work at home and then submit on the blackboard.
Okay, thank you.
So somebody asked question, what is algae relates to? So algae is a unicellular organism that lives in water, and it might prefer to live in a constant water, not a fresh water. And some algae, so algae are considered to be a transition between plants and from water to land, because they have, some of the algae, they have chlorophyll, chloroplast, and they can be a primary producer, like they can harness solar energy to make their own food. So algae, it could grow in a humid area, but it could prefer water also. Mainly water, which is lying stagnant, may not be a moving like water, like river or ocean. It could be present at the bottom of the oceans as weeds, yes.
So it relates to stagnant.
Excuse me?
It relates to stagnant in the water, you say?
No, I said that, so algae are living organisms, right? So each living organism, they want to live in their own space that suits them. So they prefer water, and they mostly prefer still water like reservoir, ponds. How often will be the quiz? Quiz will be after every chapter, right? So especially for the first 5 chapters, first 4 to 5 chapters. So it could be, so let's say for the sake of example, let's say we tomorrow we do chapter number 1, and chapter number 1 assignment will be due on, let's say, 5th or 6th. Then we might have the quiz on Friday. Similarly, when on Thursday, we might cover chapter number 2. So that quiz might be on next Monday, like that. So first 4 or 5 chapters are very important. Any other questions? If not, then let's go back to the syllabus. So, so last, all the exams will be in multiple choice questions. An exam will be available to you for for almost from beginning of the day, let's say 6 a.m. until midnight. So exams will be available for a whole day. Then these are the grading scales. A plus, A minus, B plus, from 87 to 89.9. So all these are on the syllabus. So these are mainly the policies for face-to-face, but coming back to our synchronous settings. In synchronous setting, you are supposed to attend the class. In asynchronous, you're not supposed to. In synchronous, you're supposed to attend the class. So in order to be inclusive, I'm teaching Monday, Tuesdays, and Wednesday between 11:30 to 2 something, and then on Thursday and Friday, I'm teaching in the afternoon. So once, any question? Somebody was asking question. Okay, so these what is listed here as week 1, week 2, it is actually day 1, day 2. So in here, we are reviewing, in the middle of reviewing the syllabus. We talked about biotechnology, historical development of biotechnology, and as I mentioned to you, biology is integrated to computational science. It is integrated to physics. How it is integrated to physics? For example, if you see MRI, right? MRI is one of the devices which is extensively used in hospitals in case there is a structural damage to our body. Or let's say if there is a growth in our body, let's say there's a sinus, somebody is having sinus of of upper respiratory or upper nasal cavity. So how will a physician look how big the problem is? So one can have MRI images taken of the sinus, right? Sinuses. And so where does MRI come from? MRI comes from physics, right? MRI was discovered for the first time in Stony Brook, which is in a state university, State University of New York. It's located in Long Island. So biology is a multidisciplinary science. You will see chemistry as you look into the structure of DNA and protein. You will see that all these biomolecules, they are made up of few atoms, few elements. For example, carbon, hydrogen, oxygen, right? Oxygen that we breathe, the carbon dioxide that we exhale, that's one of the essential component of our lives, right? And our lungs and heart, they work together to pump oxygenated blood throughout our body, and then take up carbon dioxide, and then we exhale out through lungs. If this system collapses, it's very, it becomes a very, emergency kind of a situation. So biology, in many ways, our body, our cells, it can be taken as a chemical factory, right? Metabolism, right? We consume breakfast every day morning, but what is the deeper meaning of a breakfast? That we providing energy. So although we are consuming, let's say, orange juice or bread or butter or an omelette, but actually these are broken down in our body and the energy is released as ATP. ATP, what is ATP? This is ATP is adenosine triphosphate, which is a chemical. So our body runs on chemical. If we don't understand the chemistry behind our biology, then we cannot understand the disease mechanism. And if we don't understand the disease mechanism, how we will develop new medicine? Yeah. So any question at this point of time? So if there are
no. Professor, is there a date for the midterm?
I cannot give you the date, but I can tell you that midterm we will have after chapter 5th.
You said after chapter 5?
Chapter 5th, that is recombinant DNA technology. Once we finish chapter 5, so I can give you an approximate date, not exact date. So let's say today is 3rd, right? So it's possible that we could have midterm on either 16th or 17th of January. So I'm just thinking, 16th or 17th, around that time, plus minus 1 day, we could have the midterm. But basic thing is to reach until chapter 5th and then announce the midterm. So let's say we will have quiz 1, quiz 2, quiz 3 or quiz 4 together. So quiz 1 for chapter 1, quiz 2 for chapter 2, quiz 3 and 4 quiz 3 for chapter 3rd and 4th, chapters 3 and 4th. And so that's how we will make progress. And going by this progress, I think that we could have midterm around January 16th or 17th. But once we finish chapter 5th, I will announce the midterm. Did I answer your question?
Yes, you did. Yes, you did.
Okay. Any other questions? So those who have not done the discussion board activity can go and do it after the class. So I would like to finish this class now, if you don't have any questions. And if you want to meet me, everybody has left, that also I can wait.